Hello guys, what's up? Once again, this is teacher Nicoy, and today we will discuss about the basic calculus week 6 day 1. So today you will learn about the use of the extreme value theorem in finding the maximum and minimum value of a given function at a given interval. Okay, so this is the topic of the extreme value theorem. Okay, so you only need calculator according to this LAS, or the learning activity sheet. Okay, so I will not explain to you anymore this extreme value theorem because you have your module, you can read about it. I will only explain the what you call this example. Okay, so we have here a function which is f of x is equals to 2x cubed minus 6x with the interval of 0 to 3. Okay, so here we have two steps. Okay, before we going to the steps, let's zoom in a little bit. Okay, so this is an optional way, but you can try to graph this using the GeoGebra graphing calculator. So we have here 2x to the power of 3, right? Minus 6x. Where's that? Minus 6x. Okay. As you can see in the graph, it has critical points. This one and this one, right? So as you can see, it goes up, and then when it hits this peak, it goes down again, and when it hits this peak, and then it goes up. So what we have here is we're gonna use the derivative, or we're gonna derive this function in order to get these 2 points. Where's that points? Here, these 2 points, this one and this one, because the x-intercept here, you know how to get this. Yes, when y is equals to 0, and this one is when x is equals to 0, the x-intercept when y is equals to, wait, y, this is the y-intercept and this is the x-intercepts. Okay, so here x-intercepts, this is the y-intercept. Okay, so what we're gonna do now is we're gonna use the first step, which is step 1. We're gonna derive the function. So first we copy the function, which is 2x cubed minus 6x, and then we derive it through this one. Okay, so we're gonna use the shortcut method, wherein this we're gonna separate first the constant, and then the power, we bring it down 3x, then we minus 1, we subtract 1 to the current power, then it will be 3 minus 1 is equals to 2, and then we minus 6, and the same we will do to this one, which we have an imaginary 1 here, so it goes down to 1x, and then we subtract 1, which is will make it 2x to the power of 0, and then we multiply this one, 6x squared minus 6 times x to the power of 0 is 1, and then we equate it to 0. Okay, so then this one we transfer it there, so it will become 6 equals to 6x squared over, we divide it with 6, so we can cancel this one, and this one also become 1 is equals to x squared. Then we square root it in order to get rid of this one. Okay, so we square root it, then it will become plus minus 1 equals to x. So always remember, when we have square root, it's always plus negative 1. Okay, so now we have the critical values. So let's go back to the graph. As you can see in the graph, the critical values is here extremum is -1, so we gonna okay, right there. So we have here -1 and then 4, right? -1 and 4, and this one and below is negative +1 and -4, which is the extreme value, extremum. As you can see here, he said extremum, so it is the critical points of the one of the critical points of the function. And then what we're gonna do next step is we have that step. It is called step 2. Step 2 is first we draw a box. We put this one, and then we put the values here, right? He said it is will be the function, or the interval is from x is equal to 0 up to x equals to 3. So in the graph here, it is x equals to 0 up to x equals to 3 here, over here, right? And then all other x's are, intervals are not anymore inside the interval, right? So we're gonna use this one, 3. Then what we have here, +1. Are we gonna use the -1? No more. No. We're not gonna use it because it is in the other side of the interval. So the interval is from 0 to 3 only. Okay, so 0 to 3, we have here, we get the 1. We have here 1, and then the 3, then the 0. Okay, so how to get the value of this one? We have here 0, 1, and 3. So how to get the value of 0, 1, 3? So we gonna copy once again the function, which is 2x cubed. 2x cubed minus 6x. Okay, so what we're gonna do here, we have here f when x equals to 0 is equals to 2, 0 cubed minus 6 times 0, and then we have also we're gonna place it here, f1 is equals to 2 times 1 cube minus 6 times 1, and then we have here also the 3 equals to 2 cube, okay, 6 3. So as you can see, we only replaced the x, okay, with the x value over here. So we evaluated the function. Okay, so here we have here 0 to the power of 3 is 0, times 2 it is 0, then 6 times 0 is also 0, so this is 0. Okay, so what we have here, so 1 to the power of 3 is 1, times 2 is this 2, minus 6 times 1 it is 6, equals to 2 minus 6 is -4. All right, then here 3 to the power of 3, so we have to use our calculator. Okay, so in order to make it sure, 3 times 3 times 3 is equals to 27. Okay, 2 times 27 minus 6 times 3 is, okay, just to make it sure, I know it is 18. All right, 18. Okay, then here 2 times 27, 2 times 27, we're gonna directly minus it here, minus 18 is equals to 36. Okay, so f3 is equals to 36. As you can see, always read the instruction. Here we have here, find the extrema of the function on the 0, 3. As we all know that the extrema, or the extreme values, is the maximum and minimum. And here we have here the intervals. Okay, so we have the intervals. So this is 0, -4, and 36. So what we're gonna put here is, we have here the maximum. What is the maximum? Which is Okay, so the maximum is this one, right? Okay, because it is the biggest of them three of the three. So maximum is when y or f of x, let's say f of x is equals to 36 when x is equals to 3. And then our minimum is f of x equals to negative 4 or 0. Of course, negative 4. And then when x equals to 1. So that is our answer, guys. That's how to answer this one. Okay, that's how to answer how to get the extreme values. All right, so have you learned from this one, this example? It's very easy. We have here step 1, you derive the function, and then step 2, you make this box first, or it is also optional, but you can have this in order to make it more sensible, sensible. Okay, 0, then you get who is the who has the greatest number and the lowest number. That's it. That's how to get the day 1 of the basic calculus. As we have here, this is the exercises. So we have our example is x to the power of 3. So we have also, we gotta use an example is x to the power of 4. Okay, so first, step 1, this is another example. Okay, step 1, we have to, let's zoom in here. Okay, step 1, we're gonna copy the function 6x4 minus 8x cubed, and then we derive it. So we're gonna use the separate the constant, and then you bring it down times 4x, then you subtract 1, so cube minus separate the constant, then bring it down, and then you subtract 1, so right there. As you can see, we have not used the graph yet. We're gonna check it after. Okay, 6 times 4. Wait, we're gonna recheck that. 6 times 4 is 24. X cubed minus 8 times 4 is also 8 times 3, is also 24. 24x squared. Then what we're gonna do is we get this 24x squared. We're gonna factor it, so 24x squared, and what we have remaining is x minus 1. So what I did here, this 24 is I get 24x squared, right? This is 24x squared, this has 24, and it has also x squared. So when I factor it out, the remaining is x minus 1. Okay, so equals to we have, oh, what happened to that one? So we have two values here, which is this equates to 0, right? So 24x squared is equals to 0, and x minus 1, or 0 is equals to x minus 1. So we have here 24 over 24, still 0, x squared, and we square root that. It is still 0 equals to x. Okay, and here we have we transfer it there, so it will become x equals to 1. Okay, so we have another value here is x equals to 1. So we have an interval of -1 to 2. So we proceed to step 2. In step 2, we're gonna use the box, and then we're gonna put the interval first, which is the lowest is the -1. So -1, and then here we have this one and this one. So we can put 0 also, 1, and then 2. 2. Okay, so that are the, that's the value of our x's. And then we copy once again the function, which is 6x to the power 4 minus, what is that? 6x 8x cube. Okay, so is that our function? Okay, correct. And then what we're gonna do here is we're gonna evaluate it. So negative 1 to the power 4 minus 8 negative 1 cube is equals to 6 times to the power, if you have here negative, here negative 1, and it is to the power of an even number like here, the answer should be positive, no? And here we have here negative 1 to the power of an odd number, so our answer should be negative. Okay, so 6 minus 8 times negative 1 is negative 8 times negative, so it will become plus 8, so this is 14. Okay, so the next one is the 0, which makes everything is equal to 0, because 6 times 0 is, okay, this is 0. And then we have here f was the other one, 1, which is equals to 6 times 1 to the power of 4 minus 8 1 to the power of 3. So we have here 6 minus 8, which is negative 2. And the next one is, what is it? 2. It is 2, right? Okay, negative 1 to 2. So 2 here is equals to 6 times 2 to the power of 4 minus 8 times 2 to the power of 3, which is equals to 2 times 2 times 2. So we use our calculator. 2, 2, 3, then 4. Okay, 4. 2 times 2 times 2 times 2 is equals to 16. So 6 times 16 minus 8 to the power of 2 times 2 times 2 is 8. Whoa, 8. So we have here is equals to 6 times 16 is 96 minus 8 times 8, which is 64. And we have here 96 minus 64 is 32. Alright, so our value here, we put it in the table. 14. 0 was the value of 1, negative 2, and 32. Alright, so if he said we gotta get the extreme values in the set interval, so our maximum value is f to the power, function f of x is equals to 32 when x is equals to 2. And our minimum value is what we have here, negative 0, negative 2, so negative 2, so 1, negative 2, and when x is equals to 1. Okay, so let's try to graph that. Let's try to graph it. So 6x to the power of 4 minus 8x to the power of 3. Okay, so this is the graph of the function. As you can see, it goes down during when x is equals to 1 and y is equals to negative 2. This is the critical value of the function. And also this one, 0, and also this x-intercept. Okay, so that's how we get the extreme values of the function. Okay, so hope you learned this one, and we proceed to week 6, day 2.